Welcome to Evolutionary Psychology. Together, we'll explore this fascinating frontier of understanding human behaviors through the interface of integrating psychology and evolutionary biology. Evolutionary psychology is a relatively new discipline that applies the principles of Darwinian natural selection to the study of the human mind. The principal assumption of evolutionary psychology is that the human mind should be considered to be an organ that was designed by natural selection to guide the individual in making decisions that aid survival and reproduction, leading to evolutionary adaptation by forces of selection. This may be done by species-specific instincts that enabled our ancestors to survive and reproduce, and which give rise to a universal human nature. But equally, the mind may be viewed as an organ which is designed to learn. So, contrary to what many people think, evolutionary psychology does not suggest that every feature of the mind is innate. In this lecture, we trace the origins of evolutionary psychology and present some of the arguments between those who hold that the mind is a blank slate and those who believe that human behavior, like that of other animals, is the product of a long history of evolution. Reflect for a moment on which of these camps you would place yourself in if you had to favor one over the other: blank slate or innate instincts. The fundamental assumption of evolutionary psychology is that the human mind is the product of evolution, just like any other bodily organ, and that we gain a better understanding of the mind by examining evolutionary pressures that shaped it. Why should this be the case? What can an understanding of evolution bring to psychology? Considering that scientists were able to learn a great deal about bodily organs such as the heart or a hand long before Darwin formulated the theory of natural selection. But not all body parts are as easy to understand as a heart or a hand. A classic example is the peacock's tail. This huge structure encumbers the animal to the extent that it makes it difficult to escape from predators and requires a considerable amount of energy to sustain it. Darwin was troubled by this, and he once remarked that the sight of a feather in a peacock's tail, whenever I gaze at it, makes me sick. He knew that the male peacock is evolutionarily burdened by this tail, and that his theory was inadequate to account for it. Or, to take another even more perverse example, the male Australian redback widow spider who sacrifices himself to the female following copulation. Redback widow spider mating cannibals were shown here.
Redback spiders, known for hanging out in dunnies and their nasty little bite. But have you ever stopped to think about their sex life? Biologists from the University of Toronto recently observed the gruesome antics redbacks indulge in after lights out. The female is definitely the dominant sex and can be up to 100 times heavier than the male. And she can be very daunting. This one brushes a male aside as he approaches. A smaller male sneaks into the web and copulates, while the larger male continues his courtship dance. He plucks his love ballad on her web to entice her. But she has other plans. Once mated, she's hungry for more than love. Maybe he'll survive her potentially deadly love bite. Maybe not. A sneak peek into the macabre and cannibalistic world of the redback spider.
The males of the species somersault into the mouths of the female after copulation has occurred, which has been shown to increase paternity by 65% when compared to males that are not cannibalized. Why would an animal be designed to do that? Because this increases the nutrients to the female mother, his offspring, and his own genes. Traditional psychological thinking deals with more proximate questions, which ask about how a particular behavior develops, what its neural or cognitive underpinnings are, or whether it is acquired or innate. To the extent that psychologists ever consider why we perform particular behaviors, they usually concern themselves with the benefit to the individual who performs the behavior. So, while traditional psychology focuses on smaller questions, evolutionary psychology concerns itself with more ultimate questions, asking why a particular behavior exists at all, so it can explain the otherwise perplexing behavior of the spider. We are not necessarily the beneficiaries of our own behavior. The beneficiaries of behavior are, in many cases, our genes. The peacock dragging his tail behind him might actually prefer to be rid of it. We might expect the male redback widow spider to avoid indulging the cannibalistic urges of his female mate. But placing the individual at the center of the action in this way doesn't always give us the complete picture. Modern evolutionary theory sees the individual as merely an actor performing a script that was not of his or her writing. A script written in the language of genes. If you ponder this deeply, it begins to make sense why this has to be the case. Life originated from replicating chemicals, the precursors of DNA. And only after millions of years did these chemicals start to build structures around themselves to form the precursors of cells. Unicellular organisms became multicellular, tissues became organs, until we eventually ended up with animals, complete with brains and behavior. DNA clearly benefited from the development of a body to encase it and a brain to repel it. Or these structures wouldn't have evolved. They would have been out-competed by brainless, bodiless organisms. So our genes aren't here to support us. We are here to support our genes. Counterintuitive, perhaps, to every human being. Even the researchers at the heart of the discovery stated, "This is a truth which still fills me with astonishment," by Richard Dawkins. Richard Dawkins wrote the famous book, The Selfish Gene, and the quote, "We are survival machines, robot vehicles blindly programmed to preserve the selfish molecules known as genes."
The gene is immortal. In fact, a publisher once, when I showed him the first couple of chapters of The Selfish Gene, said you shouldn't call it that, you should call it the immortal gene. And perhaps I should have done. Genes are immortal in the sense that the coded information they contain is reproduced, is replicated with almost total fidelity, significantly, not absolutely total fidelity, generation after generation after generation, such that there are genes which are identical to what they were tens of millions of years ago, hundreds of millions of years ago in a few cases. So genes are immortal, not the DNA, of course that's not, that turns over in a very short space of time, but the coded information is potentially immortal. And that means that the difference between a successful gene and an unsuccessful gene really matters. It's going to matter for millions of years. So the genes that make it through those millions of years are the ones that are good at it. And good at it means good at building bodies, good at controlling the processes of embryology, to make bodies which have what it takes to preserve those genes and pass them on. And so I use this phrase survival machine. A body, an individual, is a survival machine. And that's by far the most powerful way of interpreting what an individual organism is. An individual organism is a throwaway survival machine for the self-replicating coded information which it contains. And the fate of that coded information is crucially bound up with the fate of the body in which it sits. If the body in which it sits dies before reproducing, then that coded information is not going to go on to the next generation and the next, and potentially for tens of millions of years. So the genes that are in the world today, distributed as they are in bodies of millions of different species, are here today because they were good at what they did in the past. They've come through in a literally unbroken line of successful ancestors, where unsuccessful non-ancestors have been littered by the wayside. And so the genes in a swallow or in a kangaroo or in a hedgehog or in a human are all very, very good at making swallows or hedgehogs or kangaroos or humans. They had to be good at it, or they wouldn't have come through the generations today. Now that, I think, is an inspiring vision, and that's what fired me up about the very idea of the selfish gene. When I first read Hamilton, and then when I wrote it down first in my lectures, and then in the selfish gene.
So the idea, the genesis of the idea comes in the mid-60s from Bill Hamilton, and then it sort of lies not ignored, but not really researched further. And then some people like Bob Trivers picks it up.
Yes, I mean,
70s.
actually, to be fair, I mean, it's inherent in the neo-Darwinian synthesis of the 1930s, actually, in Fisher and Haldane. And Hamilton particularly applied it to the problem of the relationship between kin, but it wasn't only kin that inspired me. It was the very idea of the survival machine of immortal genes, which goes back to the 1930s, I think.
Richard Dawkins wrote the famous book, The Selfish Gene, and the quote, "We are survival machines, robot vehicles blindly programmed to preserve the selfish molecules known as genes." It is said that science has presented humans with multiple blows to our sense of self-importance. Copernicus taught us that the Earth was not at the center of the universe. Freud showed us that our instincts are emotional and sexual rather than rational and godly. Darwin demonstrated that we were descended not from angels, but from apes. To this we might add the gene-centered view of life, which shows that in many cases we are not the final beneficiaries of our own behavior. We are here in service to our genes. For millennia, humans have been fascinated by the natural world, not just the complexities of the organisms that populate it, but the relationships that exist between different species and how it all began. Surely such a complex system could not have arisen by accident. Surely this must have somehow been designed, created by some all-powerful being. The idea that nature in all its complexity was created all at once held sway for a long time, not just as religious doctrine, but as a true account of the origin of everything. Debates about the scientific status of creationism and intelligent design have recently approached boiling point and, in the United States, entered the courtroom. In December 2005, Judge John Jones ruled that intelligent design was not science, and therefore it is not permissible to teach it as science in the classroom. More recently, the so-called New Atheist movement, headed by Daniel Dennett, Richard Dawkins, Sam Harris, and the late Christopher Hitchens, have written provocative and in some cases inflammatory anti-religious texts. However, the purpose of bringing up religion is not to ultimately bury it, but to show how many religions were grappling with the same problems as many scientists, to understand where life came from and what it means. The ancient Greek philosopher Thales tried to explain the origins of life in terms of natural as opposed to supernatural terms. He also proposed that life evolved out of simpler elements, with the most basic element from which all else ultimately derived, being water. Later, another ancient Greek, Empedocles, suggested that in the beginning of the world, it was full of bodily organs which occasionally came together and joined up, driven by the impelling force of love. The results of most of these unions were monstrosities which died out, but a minority were successful and went on to reproduce, producing copies of themselves. Although we can clearly recognize this as being fanciful in that we now see love as a human emotion rather than as an impelling force of nature, Empedocles' mechanism has conspicuous similarities to natural selection. Aristotle seemingly killed off evolutionary thinking by proposing that each species occupied a particular space in a hierarchical structure known as the Great Chain of Being. In this scheme, which was later adopted by the Christian religion, God occupied the topmost rung of the ladder, followed by angels. Then the nobility, males and females, then ordinary men, ordinary women, animals, plants, and finally inanimate objects. Moving from one rung to another was not permitted, which meant that there was a natural order of things. By fixing the hierarchy in this way, Aristotle's view effectively closed down debate about evolutionary change. Not only would any opposing view be considered theoretically incoherent, but it was also considered morally wrong to question the way things should be. Much more recently, in 1798, the German philosopher Immanuel Kant wrote in his work Anthropology that an orangutan or a chimpanzee may develop the organs which serve for walking, grasping objects, and speaking. In short, that he may evolve the structure of man with an organ for the use of reason. In contradiction to Aristotle, Kant imagined how one organism can change over time, perhaps acquiring the characteristics of other organisms. Notice also that Kant does not merely refer to physical change. An organ for the use of reason is a psychological faculty. Kant presaged evolutionary psychology by 2 centuries. Darwin's own grandfather, Erasmus Darwin, wrote that all living things could have emerged from a common ancestor, which he called one living filament. He also suggested that competition might be the driving force behind evolution. He saw this competition occurring between different species and within a species between members of the same sex. In the laws of organic life, he states, the final course of this contest among males seems to be that the strongest and most active animal should propagate the species, which should thus be improved. Although there are close similarities between these ideas and Charles Darwin's theory of evolution, Erasmus failed to produce a plausible mechanism for evolution. A contemporary of Erasmus Darwin, Jean-Baptiste Lamarck, proposed just such a mechanism to account for change. Lamarck's first law suggested that changes in the environment can lead to changes in an animal's behavior which might cause an organ to be used more or less. The second law was that such changes are heritable. Taken together, these laws prescribe an organism's continuous gradual change as a result of the interaction between the organism's needs and the environment. Most evolutionary biologists agree that the inheritance of acquired characteristics, as Lamarck's theory has since been called, is incorrect, although the environment can indeed affect bodily organs. For example, increased exercise can increase the capacity of the heart and lungs. Such changes cannot be passed on to the organism's offspring. Natural selection depends on 2 components. The component of heritable variation means that individuals within a population tend to differ from each other in ways that are passed on to their offspring. And the second component, differential reproduction, means that as a result of these differences, some individuals leave more surviving offspring than others. The overwhelming majority of asexual offspring will be identical to the parent, but a few will be different in some way due to errors in the copying process. Should these different offspring survive and reproduce, then the majority of their offspring will be identical to them and the process repeats itself. However, copying errors seldom have positive consequences. On very rare occasions, however, an error might produce an organism that is actually better fitted to the environment. And this individual will tend to produce more offspring, and the error will soon become the norm. In some cases, the new lineage might outcompete the old and come to replace it. Sexually reproducing species, on the other hand, combine the genes of two parents during reproduction, meaning that offspring will always be different from either parent. The increased variation produced by sexual reproduction is thought to be one of the reasons why sex evolved in the first place. It provided an extra mechanism for variation, effectively accelerating evolution. Darwin knew nothing about genetics, and for good reason. At the time of Darwin's death, no one on Earth knew about genetics except for the Austrian monk Gregor Mendel. Between 1858 and 1875, Mendel conducted a series of breeding experiments on hybrid pea plants in the garden of his monastery. One of Mendel's greatest insights was that inheritance was particulate. Darwin assumed that the traits of an individual were some sort of blend of the traits of the mother and father, as might happen when mixing paint. But Mendel demonstrated that the blending model is incorrect. He found that if two pea plants were crossed, one having white flowers and one having red flowers, the offspring would be either red or white, never pink, as might be expected if the two traits blended. The reason why some traits, such as height or skin color, seem to blend is because they are controlled by more than one gene. For traits controlled by single genes, inheritance is always particulate. There were rumors that Darwin possessed a copy of the journal containing Mendel's article, Experiments in Plant Hybridization, but no copy was found in Darwin's extensive library. Generally, the scientific community was rather slow to realize the significance of Mendel's ideas. So biology had to wait until the 20th century before Mendel's work was rediscovered. Although most of Darwin's examples in The Origin of Species concerned physical traits, he also believed that natural selection had a role to play in the evolution of behavior. Darwin is thought to have seen the human mind as being explainable by the same physical laws as other bodily organs. Darwinian evolution and mechanistic view led to materialism, which is the approach adopted by modern cognitive psychology. It sees the mind as being ultimately reducible to the activity of the brain, or as Steven Pinker puts it, the mind is the information processing activity of the brain. The brain, being a physical organ, is subject to the pressures of natural selection. Therefore, the mind, and hence behavior, is at some level the product of evolution by natural selection. Darwin's cousin, Francis Galton, was highly influenced by the theory of natural selection. In his own words, the publication in 1859 of The Origin of Species by Charles Darwin made a marked epoch in my own mental development, as it did in that of human thought generally. Its effect was to demolish a multitude of dogmatic barriers by a single stroke, and to arouse a spirit of rebellion against all ancient authorities whose positive and unauthenticated statements were contradicted by modern science. Galton was a very important figure in the history of psychology. He proposed that character and intelligence were inherited traits, and developed some of the first intelligence tests to explore these issues. He was, in many respects, the father of what is now known as psychometrics. He also anticipated the method of experimental psychology by emphasizing the need to use quantitative data from large samples of individuals. Galton also proposed that traits that may have been useful in ancestral times might be less useful in contemporary society. For instance, he suggested that during ancestral times, evolution had favored humans who were group-minded or gregarious. In Galton's time, greater emphasis was placed upon self-reliance, so gregariousness might be less desirable. More controversial was Galton's attempt to suggest that those individuals whose traits might benefit society, like innovators, the highly intelligent or otherwise talented, be encouraged to produce many offspring, and those whose traits are seen as less desirable be discouraged from reproducing, a controversial program that he called eugenics. The word eugenics, coined by Francis Galton, comes from the Greek word eugenes, meaning well-born. It was developed as a method of trying to dictate who breeds with whom and, in extreme cases, who doesn't breed at all. His idea is expressed in the lengthy quote to the right. When Galton founded the Eugenics Education Society in 1907, the goal was to improve the human species by positive means. if a 20th part of the cost and pains were spent in measures for the improvement of the human race that is spent on the improvement of the breed of horses and cattle, what a galaxy of genius might we not create? We might introduce prophets and high priests of civilization into the world as surely as we can propagate idiots by mating cretins. Men and women of the present day are to those we might hope to bring into existence what the pariah dogs of the streets of an eastern town are to our own highly bred varieties. The idea was also Greek. In the Republic, Plato proposed that although friendships between the sexes should be permitted, procreation should be controlled by the government with the aim of breeding a better society. There are two forms of eugenics, often called positive and negative. Positive eugenics operates by encouraging people with high fitness to mate together and produce many offspring. The word fitness here can be treated as meaning possessing characteristics which are thought to be good for society. Negative eugenics, on the other hand, attempts to curtail or prohibit reproduction among those who are considered unfit. This form of eugenics is anathema to most people. Charles Darwin's son, Major Leonard Darwin, took over the Eugenics Society from Galton and instigated the transition from positive to negative eugenics. He proposed that a policy of segregation should be implemented whereby the fit were separated from the unfit. Compulsion is now permitted if applying to criminals, lunatics, and mental defectives, and this principle must be extended to all who, by having offspring, would seriously damage future generations. In the early part of the 20th century, hundreds of thousands of people were sterilized worldwide on the grounds that they were deemed psychologically unfit. In the United States alone, it was reported that by 1960, almost 60,000 individuals had undergone involuntary sterilization. The largest and most systematic program of eugenics occurred in Nazi Germany, beginning with segregation and sterilization and finishing with a systematic slaughter of millions. Hitler tried to ensure that the genes of the unfit, especially Jews, but many others as well, wouldn't make it to the next generation. Perhaps many eugenicists probably felt that they had humanity's best interests at heart. However, today, most would probably feel that even positive eugenics, with its attempt to coerce or interfere with an individual's freedom of choice of sexual partner, is an infringement of civil liberties and therefore abhorrent. Let's explore a story related to these issues.
You keep your workstation so clean, Jerome.
It's next to godliness. Isn't that what they say?
Godliness. I reviewed your flight plan. Not one error in a million keystrokes. Phenomenal. It's right that someone like you is taking us to Titan.
Has the committee approved the mission? There's been talk of delay.
You shouldn't listen to talk. You leave in a week. You've got a substance test.
Congratulations, Jerome.
Thank you. The most unremarkable of events. Jerome Morrow, Navigator First Class, is about to embark on a one-year manned mission to Titan, 14th moon of Saturn. A highly prestigious assignment, although for Jerome, selection was virtually guaranteed at birth. He's blessed with all the gifts required for such an undertaking, a genetic quotient second to none. No, there is truly nothing remarkable about the progress of Jerome Morrow, except that I am not Jerome Morrow. I was conceived in the Riviera, not the French Riviera, the Detroit variety. They used to say that a child conceived in love has a greater chance of happiness. They don't say that anymore. I'll never understand what possessed my mother to put her faith in God's hands rather than those of her local geneticist. 10 fingers, 10 toes, that's all that used to matter. Not now. Now, only seconds old, the exact time and cause of my death was already known.
Neurological condition, 60% probability. Manic depression, 42% probability. Attention deficit disorder, 89% probability. Heart disorder, 99% probability. Early fatal potential. Life expectancy, 30.2 years.
30 years.
The name for the certificate?
Anton? No, Vincent Anton. Yeah, that's a good name.
I know he'll do something. He'll do something. Vincent?
From an early age, I came to think of myself as others thought of me.
Vincent?
Chronically ill. Every skinned knee and runny nose was treated as if it were life-threatening.
I'm sorry, the insurance won't cover it. If he fell...
But I was told that everything was
I
gonna be
really
all-
wish there was something I could do.
Like most other parents of their day, they were determined that their next child would be brought into the world in what has become the natural way.
Your extracted eggs, Marie, have been fertilized with Antonio's sperm. After screening, we are left, as you see, with 2 healthy boys and 2 very healthy girls. Naturally, no critical predispositions to any of the major inheritable diseases. All that remains is to select the most compatible candidate. First, we may as well decide on gender. Have you given it any thought?
We would want Vincent to have a brother, you know, to play with.
Of course you would. Hello, Vincent. You have specified hazel eyes, dark hair, and fair skin. I have taken the liberty of eradicating any potentially prejudicial conditions, premature baldness, myopia, alcoholism and addictive susceptibility, propensity for violence, obesity, etc.
We didn't want, I mean, diseases, yes, but...
Right. We were just wondering if it's good to just leave a few things to chance.
You want to give your child the best possible start. Believe me, we have enough imperfection built in already. Your child doesn't need any additional burdens. And keep in mind, this child is still you. Simply the best of you. You could conceive naturally 1,000 times and never get such a result.
Ponder this. Currently, there is controversy about the role of genetic engineering in determining human traits. It is already possible to screen fetuses for genetic disorders, and soon it will be possible to replace defective genes to produce a healthy infant. Some worry that genes might be replaced that are not medically deficient, merely undesirable. If it were possible to detect genes that influence criminality or antisocial personality, would it be ethical to change such genes for the common good? Would it be morally right to genetically manipulate genes for intelligence or good looks? The eugenics controversy has cast a shadow over the use of Darwinian theory in explaining human behavior. it has been all too easy for all evolutionary theories to be dismissed and inherently racist, supremacist, or otherwise politically incorrect. This is unfortunate because Darwinian thinking could well prove to be the framework that unites the social sciences, in the same way that it unified the disparate areas of biology in the early part of the last century. The fact that we do not like the implications of a particular theory does not affect its truth. On the other hand, it would be a mistake to think that science exists in a vacuum. And it is incumbent on all of us to guard against those who might wish to use the results of science for their own political ends. William James is one of the most influential psychologists of all time. He made the distinction between short and long-term memory, still used to this day by modern cognitive psychologists. James had a keen interest in the nature of consciousness and was very much interested in applying Darwin's ideas to human psychology. In particular, he outlined instincts such as fear, love, and curiosity as driving forces of human behavior and commented on the misconception that nothing is commoner than the remark that man differs from the lower creatures by the almost total lack of instincts and the assumption of their work by reason. He went on to add that human behavior might be characterized by more instincts than other animals rather than fewer, an idea that has been embraced by modern evolutionary psychologists such as John Tooby and Leda Cosmides. Whole systems of psychology have been founded on this assumption. The concept of instinct was dropped from some social scientists' terminology in the 20th century, partly because it was considered too imprecise a term to be scientifically meaningful. A new approach to the social sciences denied their existence and saw culture rather than biology as being the principal determiner of human behavior, further stating that many so-called instinctive behaviors are capable of being modified by experience, so it is difficult to see where an instinct finishes and learning begins.